Hi, I'm James the Light Guy, and today we're going to take a look at a set of LED replacement headlight bulbs from Wontolf. These bulbs are available on Amazon, and I will put a link in the video description below if you'd like to get them for yourself. These bulbs are fairly expensive. They cost me $51, and this video was made possible with the help of our Patreon supporters. Consider visiting the Patreon page and supporting the channel to help fund more videos like this. Inside the box we get 2 bulbs and 2 wire adapters. Let's get this out of the way. These bulbs are very similar in design to the CarWorks box LEDs that we covered in a previous video. I will put a link to that video down below as well. I actually reached out to the manufacturer of CarWorks box to confirm, and they say that this is a clone of their design, an unauthorized clone at that. But we'll go over some of the similarities and the differences between the sets. Let's zoom in a little bit here. Starting with the harness end, as always, this is in H11 bulb type, and we can see that it has a fairly soft plastic electrical socket there with some decent strain relief to a nylon braid sheath here. Now this wire sheath is actually pretty impressive because it feels like the internal power wires are protected by a normal thicker rubber sheath and then the braid over that. Then we have a simple 2-pin connector with a key. That key, bump the camera. That key slots into the other end here. So this male end slides into the female. It has ribbed plastic on there, so once it's in, it is a fairly strong connection. Then we have more of that thick, sturdy braid to the brain box. Now this power controller says 120 watt, 6000 K, 20,000 lumen. Now the listing says that that is per pair, so we should expect this to run at 60 watts and be 10,000 lumens. We'll confirm or deny that with our power supply in a bit, but this is just a simple stamped metal housing, and supposedly the components inside are CAN bus. So the decoder in here should eliminate any flickering or bulb out warning if you have a newer import or smart car that tells you when you have a headlight out. Next is the braided sheath between the control box and the light, and if I get in close and can get the focus right, you can actually see the wires inside this sheath. So this section of wire is much less protected. I mean, the sheath does do a fair degree to protect the wires, but not nearly as sturdily as the far end over here. Moving on to the bottom of the bulb, we have a decent thermal mass on this heat sink. There's not a huge amount of surface area, but it is narrow, and you can see how close to the base plate adapter it is. So shallow housings, this would be very useful for. However, there is no protection on the back of this cooling fan, which is going to pull in an awful lot of dust and debris in through the back and try and force it through these small holes here. Moving up to the base plate adapter itself, you can see that it is retained by 2 keyed tabs here on the bulb and has the vertical channels for that to slide up, and a horizontal channel or groove to retain the adapter on the bulb. This does give you the freedom of, once installed in the vehicle housing, to turn the bulb slightly to try and get that proper 9 o'clock, 3 o'clock alignment of the chips for the best beam pattern. Moving up, we can see the same chrome-plated shroud around the chip boards. Unfortunately, the screws holding this in, once removed, don't actually give you access to pull the shroud off, as they then the chip interferes in this window to get it off. So I couldn't confirm whether or not the boards had a copper substrate, but it did offer a lot of heat transfer down to the heatsink, so it's quite possible. Let's get a close-up of these chips. There we go, move a little bit further back. You can see that we have two opposing 6 LED chips. They appear to be the same as the CSP chips on many of the other bulbs, but this didn't come with any documentation. The listing does say CSP chips, but again, it didn't come with a manual, which the listing says it should. So lots of things against the listing so far. Let's grab our power supply and turn it on and see how much current it draws. All right, we have the bulb hooked up to our power supply now. We'll turn that on. And you can see at 14.4 volts, we are drawing 2.9 amps and rapidly dropping. The bulb is surprisingly bright in the hand, and there is that dark spot, but the chrome plating on this shroud does help compensate for that. This does have an incredibly loud fan. Let's bring that closer to the mic. But as I've said in the past, these fans are virtually unnoticeable when inside a housing or with an engine running. You can see we've already dropped down to 2.78 amps and continuing to drop. So what I'm going to do is I'm going to let this finish warming up and see at what amperage we stabilize. I'm back. It's been about 5, maybe closer to 10 minutes now, and we've nearly stabilized at 2.3 amps or 2.35 amps, which is over half an amp less than where we started. That puts us roughly a little over 30 watts for the bulb. Another thing to note is that the bulb itself is very, very cool. I can just touch it, no big deal. This control box, however, you could probably cook on, because touching it for more than half a second will probably burn you. So that is something to be concerned about. All right, let's grab our light box and get a couple of quick free measurements. As always, we're going to be running this test in the times 10 function of our meter. We're going to start with the darkest side facing the sensor and then move to the brightest, give us a full range. So, darkest side, as you can see, we are at 480 lux, 473, 469. Figure out where that darkest spot actually is. There we go, 460. and we'll turn it to brightest, and looks like 1600. That's a far cry from the 10,000 per bulb that the listing claims. Let's put these in a housing and see what the beam pattern looks like. We now have the bulb installed in our reflector housing with the chips at the 3 and 9 o'clock position. We're lined up with our support column with the beam centered on this wall. We're going to use our standard points of reference here on the left, 3 points in the center, and 1 here on the right. Starting with the left point on the oncoming traffic side of things, we got 28 lux. The center high spot had a peak brightness of 343, and then the woods side or right side of the beam pattern had 36 lux. Going vertically, as I said before, the hot spot here was 343. This one dropped down to 181, and all the way down here in the shadows, we had a mere 17 lux. Looking at the beam pattern overall is decently sharp on this cutoff across the top. A little bit of excess light being shed up over the top, but surprisingly little overall. And you can see we don't have any major dark spots here in the beam. That chrome plating does a great job in reflector housings of evening out the beam pattern. Let's put them in a projector housing and see how it does. The bulb is installed in our projector housing, still lined up with that support beam, and running through the same test. Over here on the left, we got the same light output, 28 lux. Moving over here, significantly lower, we got 170 lux, so less than half, well, just about half the brightness as the reflector housing. And over here, once again, identical, 36 lux. All right, going vertically, again, we had 170 here at the top, 123 in the middle, and down here, not quite as dark as the reflector housing, we got 32 lux. So actually almost double what the reflector was down here. It looks like the projector does a better job keeping an even spread of light, but significantly reducing it with these particular bulbs. So let's move back to the studio for our conclusion. Back in the studio, and we can talk about these bulbs. First, I want to once again thank the supporters on our Patreon for helping make this video possible. And don't forget to like, share, subscribe, and follow me on Instagram and Facebook. Next, our conclusion. So these are clearly similar to the CarWorks box LEDs that they were design copied from, but they're at a higher price point. Like I said in the beginning, they're $51 for the pair, and their claims of 120 watts was significantly off. We were at like 32 after it stabilized, and the lumens you saw peak brightness was around 1600 out of a housing. Once in the housing, that dropped significantly. The bulbs themselves didn't get hot, so this heatsink is a great design. The bulb itself seems very durable, and longevity-wise, this half is great. My point of contention is this brain box. This power controller got so hot that I was afraid that anything that was touching it was going to burn. I don't recommend these bulbs personally, just because of how hot this control box gets, and I don't know how susceptible to heat damage the components inside are. I mean, 10 minutes and I swear you could cook food on it. Maybe we'll do that in a later video, maybe a video just for patrons or on Instagram, just a quick, test. Can we cook an egg on this power supply or power controller? It'll be fun. Anyway, that's all I have for today's video. If you enjoyed it, hit that like button for me and share with your friends. Until next time, I'm James the Light Guy.